And we are recording now. Okay, now if you want to copy down what I have drawn here, you may want to pause this video so that you can do that, because there's a lot of information on this video that is done beforehand, the prep work. This thing says 3 forces, and again, stop it now, copy it down, and then start it back and we'll finish it up. Okay, this says 3 forces of a magnitude of 65, 105, and 120 pounds acting on an object of 35 degrees, 45 degrees, and 115 degrees, respectively, with the positive x-axis. So that means I've drawn all my direction angles for each one correctly. So you have vector U in red, vector V in green, vector V in blue, and vector W in green. And all those angles are drawn correctly with the x-axis being the initial rate of that angle. It says find the direction of magnitude, the resultant of these forces. Now I drew the resultant as this purple one right here, but I don't know where this purple one's going to lie. I know it's going to lie somewhere between the green and the red vector. Somewhere between those. I'm just arbitrarily placing it right here. If you will remember, resultant means that it comes from adding all the vectors together that work against it. So I have vector U, vector V, and vector W. I'll slide this over a little bit. So if I add U and V and W together, which you'll see right here, U plus V plus W, that's going to give me my vector Z, which is this purple vector, the resultant vector. Well, to do that, I need to find my components. And we learned from the previous video that when your vectors are not along the horizontal or the vertical axis, then the way you find them is you use your angle and the magnitudes, and you just simply do the cosine to find the horizontal component of that vector. In other words, the x direction, the bottom leg of that right triangle, and the sine to use the vertical component. And if you look here on the right, and I'm circling it with my black marker, that's the math done for you right there. And the numbers have been checked out, and they seem to be correct. So what I did was, for example, for vector U, this is the horizontal component, that's the vertical, and when I take 65 and multiply it times the cosine of 35 degrees, I get 53.24. And when I take 65 times the sine of 35 degrees, I get 37.28. And I did the same thing with vector V and vector W, and so I got my 3 vectors down here, and I wrote them out. This is vector U, this is vector V, and this is vector W. And yes, notice you have a negative right here, and that negative is fine. That's supposed to be there, that negative. Now let me slide that back out of the way. Right? We don't want that. That negative is supposed to be there because that angle is in the second quadrant, so you're going to get a negative cosine. But when you add them together, you get vector Z has the components 76.78, 220.29. Now this 76.78 comes from taking the x component of all 3, 53.24, 74.25, negative 50.71. Add them all together, you get 76.78. The y component comes from adding all the y individual components together, and you get 220.29. Now this is great. This hasn't answered the question. We need to find the direction and the magnitude of that resultant vector. To do that, we need the components of the vector. Now the rest of the work is fairly straightforward. So to find the magnitude of Z, you just simply take the square root of the square of each of the components and add them together and take that square root. Okay? So if I want to use my calculator, 72.78 squared. So I have this. I have, let's clear that. Let's clear everything. 72.78 squared plus, what was my other one here? Let's see if I can move this. Oh, that's nice. 220.29. And then I'm going to take the square root of that answer. And I get 232.00132. So the magnitude is 232.001. We'll just call that 232. So that's the magnitude. And if you will recall, the direction angle, I'll minimize this right here. The direction angle comes from the arctan of those two things right there. So if I take my direction angle theta, it's going to be the arctan of, and all I got to do is put my components in. The x component, excuse me, the y component divided by the x component. Right? And so if I want to use my calculator then, what I have is the arctan, clear this out, second tan, right, of, calculator won't go any farther. I forgot my numbers. You guys help me out here. No, never mind. 220.29, 76.78. 220.29 divided by 76.78. I hope I type those in right. All right. Now, I get an angle of 70.78 degrees. That's in quadrant 1, so we're good. So our direction angle is 70.79 degrees. I did it 2 decimal places. You can only go to 1. You can call it 70.8 degrees. 70.8 would work just as fine. But since it's in quadrant 1, then we just leave it like it is. Had this angle been bigger than 90 degrees, we would have had to add 180 to it. Had it been bigger than 180 degrees, we would have also added 180 to it, because what you would have gotten was a negative angle in there. And had this angle been bigger than 270, we would have added 360 to it. Now, when I say the angle, had the vector been in the 4th quadrant, that's what I mean by that. Okay, so the direction angle then is 70.8 degrees. So that's 70.8 degrees to go up to here. And then the magnitude of this vector was 232 pounds.